This is example 3C in section 4.7. We are asked to get the derivative of this product. So the first thing we're going to do is make the expression in terms of exponents. So I'm going to turn that 1 minus 3x squared into the exponent a half. We see that we have a product of two different functions. So when we calculate the derivative, we are going to use the product rule. So the product rule says keep the first function and multiply it by the derivative of the second function. Now when we calculate the derivative of the second function, which is this one right here, we notice that we have to use chain rule because we have a composition of two functions. So we're going to work with the exponent first. So the power rule comes into play here. So the half brings down, and then you keep the function. You subtract 1, which gives us a negative a half, but then you have to go inside and look at the derivative. And the derivative of the inside function is negative 6x. You continue with the product rule, so you go plus. So now we write the second function as it is, and you're going to get the derivative of the first function. Now again, when I get the derivative of this expression, we also have another chain rule with this exponent. So the 5 is brought down, you keep the function, your new exponent is 4, but then you have to look inside. What's the derivative of x squared? It's 2x. What's the derivative of 4? 0. So this is your derivative, but we're going to do some work and simplify it. So when I look at the first expression, I see that I have a half of a negative 6x, so that will give me negative 3x. I have x squared plus 4 to the 5. And I also have this negative exponent, which I'm going to make positive by moving it to the bottom, or denominator. Then I go plus. Again, I have this 5 and 2, which gives me 10x. I have 1 minus 3x squared to the half. And I have this x squared plus 4 to the 4. So we're just going to look at tying this up a little bit more. I notice that I have a denominator, and this is all over 1. So I'm going to get a common denominator. So this expression in my denominator with an exponent half can be written as 1 minus 3x squared with a radical because the index is 2. So I don't have to do anything to the first function. It stays as is. But I need to multiply this denominator by this radical. And when you multiply the denominator by that radical, so I'm going to multiply it by 1 minus 3x squared, you notice that you're going to also multiply the top as well. And this radical with this radical, they're the same. So that means the radical will cancel. So I will just have 1 minus 3x squared. I still have the x squared plus 4 to the 4. The reason why I got a common denominator was I wanted to see some common terms, and I do have some common terms, which is like a GCF. So I see that the monomial has a common term x. I know that I can take out an x squared plus 4 to the 4, and then I'm left with negative 3, but I'm still left with x squared plus 4 to the 1. I'm going to be left with a 10 because I'm taking an x out, and I'm still going to be left with 1 minus 3x squared all over the radical. And then I'm going to, one more step here, I have an x squared plus 4 to the 4. And let's see if I can do some common terms. So I'd have negative 3x squared, negative 12 plus 10 minus 30x squared. And my last step is to just simplify that numerator. So the last term I'm going to have is x squared plus 4 to the 4. I know I have like terms, so I'm going to have negative 33x squared. I got subtract 2 with negative 12 and 10 all over the denominator. And that's the final answer.